example number 1, suppose a firefly flashes twice in the first minute. So that's term 1. 4 times in the second minute, 6 times in the third minute, and so on. So this is our sequence here. Term 1 we know is 2. Term 2 is 4. Term 3 is 6. And our D value is 2 because we're adding 2 to get from term to term. So they're saying at a certain time, he will flash 84 times. What is the total number of flashes? Okay, so we first need to find out when he has flashed 84 times. So we're going to find using that general form equation for arithmetic sequences, we're going to substitute the values that we know. So we're trying to find out when, at what minute he's flashed 84 times. So 84 equals term 1, which is 2, plus our n we don't know, our d is 2. So we can subtract 2 on both sides, and then we can divide this answer by 2 to get rid of that. So 84 minus 2 is 82. Divided by 2 is 41. 41 now equals n minus 1. And then you add 1 to both sides, and you get that in the 42nd minute, that's when he flashes 84 times. Now we're going to do something different, something new, where they want us to know the total number of flashes. Well, what you'd want to do is now add between all these terms until you get up to the 42nd term. That's a lot of work. So there's an equation that we will use instead. We will use this equation, n over 2, which is t1 plus tn. Sn represents the sum of your terms. What do your terms add up to? N represents how many terms there are in the sum. D is still your common difference. And T1 is still your first term. So the first formula, this is going to be called your second formula. So the second formula is taking your Sn equaling your n, how many terms you have, divided by 2, and adding your first term and your last term of that sum that you're trying to add together. So Tn in this case represents the last term in your sequence. So n, we know that we're trying to find the sum of 42 terms. So it's going to be 42 over 2. And then your first term is 2, plus your last term we know is 84, because that's how many times he's flashed at that 42 minutes. So we're just going to put that into our calculator, which is 42 divided by 2 is 21. And then you have to do brackets when it comes to bed mass. You have to put those together to get 86. So 21 times 86 is 1,806, and that's the total number of flashes. So that's your answer for example number 1. So we needed 2 pieces. We needed to find out when he flashed the 84 times, and that would give us the answer. That's how we found out our final answer. Our first formula, there's another formula that we can use if we're not given the last term of the sequence, and this is this longer one, but it helps us if we don't know how many flashes he's done in the, for example, the 80 in the 42nd minute. So if that information was not given, we would use this equation here, where it's still finding the sum of the series. So a sum of a series is just now you're adding up the terms. Instead of just listing them with commas, now we actually put a plus sign and add up the numbers to see what they equal. So in this case, it says the sum, example number 2, the sum of the first 2 terms of an arithmetic sequence is 19. So S2 equals 19. The sum of the first 4 terms is equal to 50. So this information is given. What are the first 6 terms of the series and the sum of 20 terms? Well, there's a lot of information we're missing, so we're going to start by putting this into the equation. So this is where we have, this is n and this is tn. Or sorry, yeah, so that's that's our Sn, sorry. So this is our, the 4 represents our n, and the 50 represents our Sn. So we're going to use the first equation for this. So we're going to say 50, which is Sn, is equal to 4 divided by 2. So I'm starting with the second equation for some reason. 2 times your first term plus n, which we know is 4. 4 minus 1 times your common difference, which we don't know. So we have two unknowns here. So 50, we're just going to simplify this. 4 divided by 2 is 2. 2t1 plus 3d. Now we're going to multiply everything by 2 to get rid of our brackets. So that's 4t1 plus 6d as our first equation that we're going to have to set up. So that's a linear equation there. Now we're going to do the same thing for this S2 equals 19. So we're going to go 19 equals 2 over 2, 2t1 plus 2 minus 1d. So that's going to equal 1, which we don't have to write. So this is 1. That crosses itself out, leaving us with 2t1 plus 2 minus 1 is 1 times d, which again, we don't have to write a 1 in front of our, in front as a coefficient. So as you can see, I can use either elimination or substitution. So I'm going to do substitution just to kind of show you how that works. So I'm going to bring this 2t1 to the other side. So what I'm doing is I'm solving for d. So that's my new equation that I'm going to use. Now I'm going to substitute this value of d into the other equation. So this is substitution that I'm doing. 50 plus, or 50 equals 4t1 plus 6 times, instead of d, you're writing 19 plus 2t1 in brackets. The 6 needs to distribute because we're going to isolate for the t1 by getting them together. 6 times 19 is 414. And then 6 times 2t1 is going to be plus 12t1. These two guys can go together, so that will be 50. And we're going to bring the minus that 114 to the other side by subtracting 114. So 4t1 plus 12 is equal to 16t1. Give me one sec, guys. There's just something seems off. Oh, I see my error. When I brought this over, I didn't change this to a subtraction. Okay, so this should be subtraction when I substitute. I'm just going to fix that because my answers weren't making sense. So it should be then 19 minus 2t1. There you go. That's better. So this should be then minus 12, which will be then 4 subtract 12 is equal to minus 8. Minus 8t1. So 50 minus 114 equals negative 64. And then we're going to divide both sides by negative 8. And you should get that your t1 is equal to positive 8. So that makes more sense. Okay, so if t1 equals 8, now we can solve for, it says we want also our common difference. So we're going to use the equation 19 minus 2t1 equals d. So 19 minus 2 times 8, which is our first term, equals d. If we put that into our calculator, D should equal 3. So 19 minus 16. So now that we have our first two terms, we have our first term, so we have our T1, we have our value of 3. For our common difference, we can find the first 6 terms of the sequence, where it's 8. Our next term would be plus 3, so that would be 11. Then we have 14 if we add 3, and we can keep adding 3 until we have the first 6 terms, and that was answering one part of the question. They also want us to find the sum of 20 terms. We need to use the first equation because we don't know the last term of the sequence. We don't know what the answer for the 20th term is, so it's better to use the SN equation where we're trying to find the sum of 20 terms. The first equation, which is 20 over 2, 2 times our first term, which is 8, plus n, we know is 20, subtract 1 times our common difference, which is 3. So that's going to be 10 multiplied by 16 plus 19 times 3. If you follow BEDMAS and you calculate that, you should get that the answer is 730. So there's 700, so it adds up to 730 if you were to add up the first 20 terms together. Example number 3 is we have a trapezoid shape being formed from cans. They're saying that there will be 10 rows in the trapezoid, so n equals 10. Our first term, we're going to start from the bottom because that's what's given. So we're going to start with 100 cans in our bottom term. And we know that every row above that, our common difference, we are subtracting 5 cans to go from term to term. So anytime we go from a row to the next row, we would subtract 5 cans. So this would help us create our equation where we're finding the sum of 10 rows. 10 over 2, we're using the first equation again because we don't know how many cans are in the top row. 2 times our first term, which is 100, plus n, 10, minus 1, times our common difference, negative 5. So that's going to be 5 times 200 plus 9 times negative 5. So if you put that into your calculator, you'll get 775 as your answer. So there's 775 cans in this structure. Example number 4 is just working with fractions. So we would rewrite this 141. It's the same as saying 143 plus 1/3. This is how you would rewrite it. So in order to rewrite this, what you're doing is you're getting a common denominator. So you can multiply this by 3 and the bottom by 3. So 143 times 3 would be 429 plus 1. We're dividing this number by 3. So 429 plus 1 equals 430. And then if we simplify 430 over 3, that would be our answer. Okay, so this is the same format, but this one was trying to remember the names of them. There was improper fractions. So this one's an improper fraction. So we want it that way because we don't want to write it like this where we have a whole number and a fraction part. It's better to write it in where you have a numerator and a denominator. So our S20 is going to equal 430 over 3. If you remember a different way, another way to find this is where you multiply these two numbers and add the top. So that's another way to write this as an improper fraction. So multiply your numerator, your coefficient times your denominator, and then add the top. The denominator stays the same. So I can do the same thing here. 10 and 1/3 is the same as saying 10 times 3 plus 1 over a common denominator of 3. So that's going to be 31 over 3 for your term 20. So once we have that, they're asking us for determine the first 3 terms of the sequence. They're giving us the arithmetic series. So we can actually use the second formula, Sn equals n over 2, because we don't know what term 1 is, but we have everything else. We do know that the last term in the sequence is term 20, so we do have that. So this is the equation we're using, where S20 is 430 over 3. N is going to be 20 over 2 because we have 20 terms in the sequence. T1 is what we're trying to find, and Tn is what is in the 20th spot, so that's going to be 31 over 3. So 430 over 3, we are equaling 10, and 10 is going to distribute into the brackets. So that's going to be 10t1 plus, whenever we multiply a whole number with a fraction, it only affects the numerator. So that's going to be 310 over 3. Continuing on, we have 430 over 3 equals, we're going to have to subtract both sides by 310 over 3. Now, 430, whenever we subtract or add fractions, we need common denominators. So we're going to just subtract the numerators together because they are common and get that this is 120 over 3, which is 10t1. 120 divided by 3 is 40. And then 10t1, when you divide both sides by 10, you should get that the first term is equal to 4. So we know that our first term in the sequence is 4. And then what we're going to do is we're going to keep adding the common difference of 1/3 to get to the next term and the next term after that, because we want the first 3 terms of the series. So we're going to have to say plus, the next term would be 4 plus the common difference. Always get common denominators by multiplying the top and bottom by the 3 in this case, and you'll get 13 over 3 is the second term. And then you would take 13 over 3 and add again the common difference. So you're just taking term after term and adding the common difference to get that you have 14 over 3 as your next term in the series. And so that's what they wanted for the answer, the first terms of the series. Okay, so that is lesson